Okay, let's just a little bit, little recap of modulators, demodulators we have studied. So basically, we have bit stream that modulate is modulated to reasonable frequencies. Uh, those frequencies are then transmitted on the receiver, and they are made again demodulated, and we get the bit stream back. So this is a very standard communication method. It's used over telephone, radio frequencies, fiber optics, coaxial cable, and with the serial port communications. USB also. So all of this. So basically, it started when we had two computers or teleprinters which could communicate with each other long time ago, so that you could send a telegram or a complete book or something like that. So you would type something on one side that would be called data terminal. Uh, that would be one data terminal equipment that will be connected to data communication equipment DCE, and over telecommunication channel it will connect to another teleprinter. And whatever you typed here, if you press enter, that printer will move the page forward. The same thing would happen on the other side. If you press line feed over here, a line feed will happen on the other side. So all the control characters were there using all that ASCII notation. So this is a uh, graph of a telephone line, which is what we call copper copper wire, a copper pair, uh, a drop wire. It's sometimes called so many names for this. So DC level 0 and 5 cannot be transmitted on this telephone line. So this is a typical characteristic of a dial-up modem. So simple FSK modem, yeah, frequency shift keying modem that we talked about. Uh, we can have two simple frequency oscillators. I have written 1200 and 2400, but in practical it is about 1000. You can say near about 1000 and 1200. But just for pedagogical reasons, I've just shown these two frequencies. So uh, you send this signal, it is received over here, and if this signal has this frequency, this output is one. So these two frequencies are transmitted, and on the receiver end you have two filters that would this would only filter output one when this signal is contains a frequency of 12 hertz, and same here with 2400 hertz crystal sorry filter. So they were combined together to recover the original waveform here. So this was called simple FSK model. So then came another one, that was phase shift keying. So phase shift keying means that you have the reason for phase shift keying was uh, PLL. PLL was a completely solved problem. And it was such a wonderful thing to have that even when you were transmitting this signal, this frequency over here, which had embedded clock in it, using all that we talked about, non-return to zero encoding and things like that. And this on the receiver end, you could recover that clock. Same was the case with this uh, at this higher frequency levels, that you could send embed a carrier frequency that the receiver end would have the same, exactly the same frequency clock, a sinusoidal waveform. So when the and because of PLL, you could have a continuous synchronous sinusoidal waveform over here, which was totally in phase with the one which was transmitted here, because PLL would ensure that both oscillators on the receiving end and the transmitting end had exactly the same frequency. Then it became very simple to know if the signal was in phase and a signal was out of phase. And using this in phase and out of phase information, you could should send 1 and 0, 1 0. So if the signal was totally in phase with the input, like this one, you would send 1. When it was out of phase, you send 0, and so on. So this would be called frequency phase shift keying, and this was only possible because of phase lock loop. Phase lock loop could easily tell you whether a signal was in phase with some other signal, or it was 180-degree out of phase, and so on. So then came the FM modulation, where you could send for zero, you could send uh, smaller frequency, and for one, you could send higher frequency. So 0, 1, 0. So 1 means high frequency, 0 means low frequency, 1 means higher frequency. As you know, uh, this FM modulation is very close to FSK, frequency shift keying. And usually, just remember this for your life, that during transmission of a signal, no matter how far you send, the frequency doesn't change. It may, due to noise, it may change the amplitude. The fundamental frequency cannot change. It may have a harmonic which are twice the size of the fundamental frequency, but the frequency cannot change. If I send 1 kilohertz signal, no matter where I send it, it will remain 1 kilohertz. So if FM from frequency point of view is very robust. That's why FM radio is much clearer and better than AM radio, because you send signal on frequency modulated signal, and like for example, if this 50 hertz frequency that we get here due to WAPDA is basically the frequency of rotation of the turbine in Tarbela Dam. So if that turbine is rotating according to 50 hertz frequency, any change will require a very huge change in the turbine, the dynamics and the mechanical component, mechanical system. So that frequency from Robda, when it comes, because of that heavy generator is cannot change along the way. The सोचें इसके ऊपर, ये और करें इसके ऊपर. So frequencies cannot change. If any distortion occurs, that is a harmonic distortion, multiple of frequencies. So the third was AM modulation. In AM modulation, what they decided, you could send, this is very prone to noise. You could send 1, 0 at lower amplitude, but fundamental frequency is same, and 1 at higher amplitude, So the phase lock loop will catch this frequency on the receiving end. So amplitude will be very easy to find out कि कब amplitude change हुआ. And amplitude इसका फायदा ये था कि it could be easily decoded using a simple peak detector that you probably study in your circuit devices course or something like that. So by simply using a diode and a capacitor, you could get the AM unmodulated signal at the output using peak detector. So this was the AM modulation. So once we had FM modulation, phase lock loop, and we had phase detection circuit very highly calibrated, very highly accurate. Then the only way to go was to increase the bandwidth. The bandwidth, there are few clock cycles are required for the amplitude modulated signal before it can go for a peak detection. So it's not just कि जो ही ये clock cycle change हुआ है, at the same time you get the output of the peak modulator. So few clock cycles are required. So that limited the time that you could spend, would have to spend for one and a zero. As a result, the bit rate would reduce. Same case with the phase detection. So the telephone line had a limit of a maximum signal you could send. वैसे अगर आप देखें तो क्या कहते हैं आपको द इफ ए banded limited signal has a frequency of 12 1.2 kilohertz and you want to transmit it, then you must sample it at twice the rate. So 24 kilohertz would be the transmission rate of a 12 kilohertz signal. पढ़ा है ना आपने ये? क्यों भाई? ज़ाहरा पढ़ा है कहीं आपने ये सैम्पलिंग थ्योरम? अब्दुल्ला? कोई भी नहीं यहाँ पे? हेलो?
सर हमने वैसे नहीं पढ़ा बट वी डिड इट इन लैब। अभी तो लैब में हमने देखा था, वैसे हमने नहीं पढ़ा।
सैम्पलिंग थ्योरम
जी सर,
क्या
लैब में
क्या
हमने देखा था।
कुछ डिफाइन कर सकती हैं
सैम्पलिंग
व्हाट इज सैम्पलिंग थ्योरम?
सर
कुछ
वही कह रही हूँ ना कि हमने एक्सप्लिसिटली पढ़ा नहीं हुआ तो हमें इतना आइडिया नहीं था, हमें लैब में भी कंफ्यूजन थी इसी वजह से।
तो फिर लैब का क्या फायदा हुआ अगर आपने शैनन थ्योरम पे लैब की है और आपको पता ही नहीं कि है क्या? ओहो. So sampling theorem says that if a band emitted signal has a maximum frequency f, you when you transmit it on a sampling rate of 2f, twice the fundamental frequency, twice the maximum frequency of a band emitted signal, then you can reproduce signal at the receiving end without any noise. It will 100% recover the original signal. So if any signal that is 12 हर्ट्ज 1200 हर्ट्ज फ्रीक्वेंसी पे जा रहा है, आपके पास है, आप उसको ट्वाइस सैम्पलिंग रेट यानी 2400 हर्ट्ज पे उसका सैंपल लेके भेजेंगे तो रिसीविंग एंड पे वो सारा टोटली रिकवर हो जाएगा. सो technically speaking, you just need maximum of two signals on the receiving end to find out what is the amplitude of this signal, technically speaking. So anyway, so AM modulation and FM modulation when phase lock loop when they were AM modulation and phase lock loop, they were perfectly uh, predictable and implementable. Then that gave to uh, this. rise to this other modulation techniques. So one of them was BPSK, which we have already talked about. Binary phase shift keying means you send a one in phase at some amplitude over here. You send 0, 180-degree out of phase at some amplitude over here. This is called binary phase shift keying. This is the most secure signal because there is a 180-degree distance between 0 and 1. Amplitude difference is also quite a lot. Sorry, only 180-degree phase difference is there. Amplitude is same. So any communication like signaling communication or modem control communication, does not have any user data, is usually done in BPSK, binary phase shift key. Then came QPSK because we could tell if the incoming signal was 45-degree out of phase or 135-degree out of phase or uh, you know two ये कितना होगा 45 plus 90 135 plus 90 225 and this is 315. So all these three could be easily जब स्टूडेंट होते थे इतनी अच्छी तरह ये सारे एंगल याद होते थे अब लगता है बूढ़े हो गए भूलते जा रहे हैं so all these could be easily identified now we could assign 2 bits to each signal if I had a signal which was 45-degree out of phase I would say okay, I am receiving 1 1. If it was 135-degree out of phase I would say I am receiving 0 1. If it was 200 and कितना बनता है ये रोशन 135 plus 90 225 नहीं 45 135 plus 45 140 plus 41 ये
तो
45
225
90
ही होता है
235
25 सर
225 so this was 225 so by measuring this angle you could tell कि ये सिग्नल जो है ना इसमें क्या क्या आ रहे हैं आपके पास बिट स्ट्रीम तो बेसिकली इसकी थोड़ी सी मैं आपको ज्यादा डिटेल से बताना चाहूंगा that for example uh, you wanted to send a bit stream like this 11010010. You want to send this bit stream through a QPSK modem. So if this is a QPSK modem, it will take 2 bits at the same time. So if this is 1 1, that means it will send क्या था वो डायग्राम में 45 डिग्री यही था ना 45 डिग्री out of phase. So this was the fundamental frequency and a 1 1 signal will be sent with the नजर आ रहा है so this would be sent as a 45-degree out of phase. So this receiver end will see if the signal is 45-degree out of phase, it will say I am receiving 1 1. And all this could be done. That was only possible because of फेज लॉक लूप. फेज लॉक लूप वाज 100% एक्यूरेट. ये ऐसा कि जिन इंसानों ने बनाया, इंजीनियर्स ने बनाया, कि इसने कम्युनिकेशन की दुनिया में इनकलाब डाला. एंड you wouldn't be using mobile phones today if there was no phase lock loop. Phase lock loop actually gets you 100% synchronized with your uh, tower. So you can really get the same frequency, same communication. So synchronization, that harmony is very important in data communication. So both of them have to be harmonized with each other before they can send data to each other. So ये understanding है, बहुत बड़ी understanding थी कि both could have the same fundamental frequency signal. So if the signal was 45 degree out of phase, you could say कि uh, 1 was being sent. Similarly, when 10 was sent, we would send a signal which was, क्या था वो, है किसी के पास डायग्राम? 10 के लिए 315 था शायद. ये के मैप की तरह ये बनाए होते हैं. दो सक्सेस साथ साथ जो हैं, इफ यू लुक एट दैट, दे आर एक्चुअली 180 डिग्री आउट ऑफ फेज. एक बिट की चेंज आ रही है, जस्ट लाइक के मैप. So 100111, so you can see this is just like a K map. So when 10 was being sent, you would send a signal that was 135 degree out of phase. This would be a signal that would represent 145 degree out of phase. So this was from starting, this was the phase difference over here was 45 degrees. Minus 45 degree. The phase difference over here was plus 45 degree. So I'm just drawing sample as a signal. The signal actually is very much, combination of fundamental frequency plus 45 and so on. I can't even draw this waveform. That's where, my wave drawing, my waveform draw करने की मेरी abilities जवाब, जवाब दे देती हैं. So this is 135 degree out of phase. या minus 45 degree out of phase. So this would be, so दो बिट्स तो ट्रांसमिशन रेट डबल हो जाता था, क्योंकि आपने दो बिट इकट्ठी भेज रहे हैं और रिसीवर को दो बिट इकट्ठी गैस कर लेता था यूजिंग फेज इंफॉर्मेशन. So you could send data that was twice the rate. So every signal change would be indicate, any phase change would indicate that we are sending two bits of data. Any signal change would indicate that we are sending 2 bits of data. So आपको इंटरनेट से वो मिल जाएंगे, आपको विल फाइंड सम सिमुलेटर्स दैट विल शो कि डाटा स्ट्रीम अगर दें तो किस तरह से कभी ये वाला डॉट जा रहा होता है, कभी ये वाला डॉट जा रहा होता है, कभी ये वाला, कभी ये वाला, और किस तरह से आउटपुट पे उस तरह फ्रीक्वेंसीज चेंज हो रही होती हैं. तो Z11 के लिए ये, 10 के लिए जीरो, सॉरी 01 के लिए ये, 00 के लिए और 10 के लिए. तो यू कुड सी दैट, जरा जूम करना, यू कुड सी कि किस तरह से ये वाला डॉट कभी जाता है, ये डॉट ये जाता है. तो चेंजिंग फ्रॉम हेयर टू हेयर, for example, changing from here to here means 2 bits of data are being changed. So information in each change was equal to 2 bits. That gave rise to the term called baud rate. So baud rate is on this diagram number of signal changes per second. So bit to baud rate, baud to bit ratio was also defined. So here baud to bit ratio is baud rate to bit rate ratio is 2. So each baud rate change would mean that 2 bits are being transmitted. So you could send actually 2 bits in one transmission. So that is called baud rate. Baud rate is changing values on this diagram. So as the time went by, uh, better and better circuits were made and more accurate information could be sent. So what happened was that they decided to change, increase this. Look at this. This is 8 PSK with gray coding. ग्रे कोडिंग मीन्स के आखिर दोनों के बीच में एक बिट की चेंज हो रही है. ग्रे कोडिंग जहां भी आपको मिलेगा आप देखेंगे कि सक्सेसिव में एक एक बिट की चेंज होती है. इसको कहते हैं ग्रे कोड. तो 111 अगर आप भेज रहे हैं तो इसमें बिट टू बाड रेट क्या होगी? ईमान आप सुन रही हैं?
जी सर.
इसमें क्या होगी बिट बाड रेट टू बिट रेट रेशियो?
सर 3.
हाउ मच?
3.
3. 3 का है ना आपने?
जी सर.
वेरी गुड, वेरी गुड, वेल डन. Yes, exactly. This is what it is going to be. Uh, so basically, that was because of this phase lock loop. So all you have are sending is a 12 hertz fundamental signal, but you are rapidly changing the phase. So that that is something that we were able to achieve higher bit rates within बैंड में. 4 किलो में अगर आप इसी बैंड में रहे तो आप इतनी ज्यादा फ्रीक्वेंसी का सिग्नल नहीं भेज सकते unless you have this phase lock loop and phase shift keying and this kind of stuff. Otherwise, the maximum signal you can send is 8 mega, 8 for 4 megabyte bandwidth limited signal. The maximum you could send was 2 megabits per second. Oh, sorry, 2 kilobits per second. On a 4 kilohertz channel, you could send 2 kilobits per second. And this is where we broke this limit by using this. All right. And now this is where we are actually getting somewhere very complex. So this is called uh, how many points are there? Only how many vectors are there? 16. So this would be called 16 QAM. Here you can assign 4 bits to each signal change. So if you are sending an in-phase signal of 1 volt, that would be you are sending 0, 0, 0. So amplitude modulation is also included. So this is called QAM, quadrature amplitude modulation. This is using combination of amplitude and phase. And this diagram is called constellation diagram. Constellation किसे कहते हैं? उसामा? What is the constellation?
सर आप इसके बारे में पूछ रहे हैं
मैं
या एज
वैसे
अ जनरल
जनरल पूछ रहा हूँ, कॉन्स्टलेशन किसे कहते हैं?
नेटवर्क ऑफ सैटेलाइट्स
नहीं,
सर
उमर, उमर, what is the constellation? अहमद,
Sir, stars की arrangement in the sky.
हाँ, स्टार की अरेंजमेंट्स जो है ना, इसको कहते हैं कॉन्स्टलेशन इन द स्काई, पैटर्न ऑफ स्टार अपीयरिंग इन द स्काई. एक बड़ा बिग डिपर एंड दिस काइंड ऑफ स्टफ, एंड ओरायन इज वेरी पॉपुलर. Orion constellation is a winter constellation. It's very, very popular. You could always see Orion in winter, even in, you know, in the city. So look for Orion and you can see what is its shape. And it is in December, January, it is right above your head, Orion. सात सितारों की टोली भी एक होते थे बचपन में, याद है ना, वो हम गाया करते, सात सितारों की एक टोली खेल रही थी आंख मचोली, चोर था एक दुमदार सितारा, फिरता था वो मारा मारा, मशरिक मगरिब, मशरिक जाता मगरिब जाता, क्या था आगे, तारे उसके हाथ ना आते, दौड़ के बादल में छुप जाते. हाँ, दोबारा सुनाता हूं मैं. सात सितारों की एक टोली खेल रही थी आंख मचोली. अ, सात सितारों की एक टोली खेल रही थी आंख मचोली, चोर था एक दुमदार सितारा, फिरता था वो मारा मारा, मशरिक जाता मगरिब जाता, सब समतों का खोज लगाता, तारे उसके हाथ ना आते, दौड़ के बादल में छुप जाते. ये आप अपने बच्चों को कभी हो मौका मिले तो आप याद कराया करें ये वाली, ये हमारी सकाफत का हिस्सा है, इस तरह की नज़में, याद है? अच्छा, ठीक है ना, सही है. सो this is a constellation diagram in modern system, the QPSK. So it has 16 stars. Each point over here is called a star. Star, star, star. So 16 stars on this constellation diagram. So 16. Uh, uh, so it can send 4 bits in one signal change. So amplitude modulation and frequency modulation are defined. Many Wi-Fi is uses these constellations when it is communicating in the beginning with the base router के साथ. आपका जब Wi-Fi का मोबाइल फोन कनेक्ट होता है तो BPS में के से कम्युनिकेट करता है. Once it connection is established, which is this is very secure. Once the connection is established, then it shifts to this one and sees if there are any errors. And the errors become errors are okay, then it goes to, depending on the signal strength, it will shift to this one. If that is fine, then it will shift to this one and it will go up to until 64 or 128 point constellation diagram, or 256 point constellation. On 256 point constellation diagram, you get the maximum speed connection with your Wi-Fi. So it basically is cancellation shifting is done according to the noise, sorry, signal strength between you and the modem router. This is 16 QM, which is a practical. Practically, it is how it is. ये तो मैंने वैसे आपको जरा दिखा दिया ना, ड्रा करके. Practically ये पॉइंट्स होते हैं 4. क्वाड्रेचर, ये एक आई होता है, इसमें एक क्यू होता है. They are quadrature to each other. This is practical 16 QAM. The most reliable is called हाफ बीपीएस के। So there you can send two streams. S is equal to 0, you send this 0, 1, 0, 1. And when S is equal to 1, you can send this and this. So basically, you are shifting between these two constellations or these two constellations. So that is half the frequency, but it is the most reliable. So these are some of the related questions that you could prepare. What is baud rate? Draw a diagram that has 64 points. What is the bit to baud rate ratio in this case? Maybe draw a picture of 32-point constellation diagram. You can search net for that. Give each point a name. इसको कह दें A, B, C, D. These are then called symbols. So symbol rate is how many symbols are being sent per second. Baud rate का एक और नाम भी होता है symbol rate. So this point over here is one symbol. This point over here is one symbol. This point over here is one symbol. So symbol rate is basically sometimes it is also called baud rate, symbol rate. So each symbol is called symbol A, B, C, D, which is attached to each star in the constellation diagram. So if you draw 32-point diagram, you can arbitrarily assign symbols to each star in the diagram. Then you can see here when you are sending this signal in this direction, what symbol is being sent on this line over here. When you are sending 64 का मतलब है कि 5 bits can be sent in one uh, transmission, one baud, one signal. यस वन सिग्नल सो 5 बिट्स तो इसमें 5 5 बिट्स का आपको जोड़ा बनाना पड़ेगा 5 बिट्स का एक 5 बिट का एक 5 बिट का एक so 5 बिट्स के यू हैव टू मेक अ ग्रुप ऑफ 5 बिट्स so then you can see here which one this one will belong to signal A B C D and so on so that way you can on the bottom of this over here you can draw the symbols that are being sent A B C D whatever is the signal that symbol that is sent. And that is another signal. This is where you can compare RS-232 with synchronous communication, where we have 100 megabytes of signal file to be sent at a baud rate of 119200 with 99% efficiency. How long it will take to send data? So bit to baud rate ratio is not given in this question. So that is a bit to baud rate ratio you can assume as 8 in this question. Baud to bit rate is ratio is 8. So calculate this. This is the kind of question you can see in the next quiz or something. So इसको prepare कर लें. This is what we are going to do next class. Null modem system in RS-232 system is that when you don't have any ground. So ground is modem in between, like you have in your class. So you connect ground to this ground, RX to TX of this, RX of this to TX of this. That is called null modem system. And these are typical RS-232 modem applications. For a system. Let's not talk in detail in that. So this is the end of the modem related discussion. Very interesting. And bottom line, if someone asks me, is the phase lock loop. Phase lock loop ने कमाल कर दी. जिन चीज है phase lock loop. It had done all of this stuff. So जो कम्युनिकेशन डायरेक्शन में जाएंगे दे विल कम अक्रॉस दिस सो मैनी टाइम्स, phase lock loop and frequency modulation and other types of modulations. So any question? So that before we can end today's lecture, any question?
सर एक बार बॉड रेट दोबारा समझा दें, और आपने बताया था कि जो हाफ BSK है वो सबसे ज्यादा रिलायबल है, तो वो भी दोबारा समझा दें एक बार।
Baud rate is signal changes per second. Look at here. I am sending a signal at if I am sending a signal in phase 1 volt signal. Assume that on this diagram amplitude is 1 volt. So stop sharing, stop कर देना, इधर कर लो यार जरा। ब्लैक वाले किधर गए मार्कर यार? वो लेके आओ जरा, 9 से। हाँ ये पड़े हैं। तो ये कितने पॉइंट बन गए? 8 होने चाहिए। 1 2 3 5 6 7 8 9 10 11 12। 12 वाली नहीं होती, 16 की होती है या 8 की होती है। आई एम सॉरी। चले खैर, डायग्राम समझाने के लिए फर्ज करें यहाँ पे एक और लगा लेते हैं। ये यहाँ पे एक और लगा लेते, यहाँ पे एक और लगा लेते, यहाँ पे एक और लगा लेते, पूरे हो गए। अब फर्ज करें कि मैं एक सिग्नल भेज रहा हूँ 1 वोल्ट का इन फेज विद द फंडामेंटल। ये फंडामेंटल फ्रीक्वेंसी है। एक मैं सिग्नल भेज रहा हूँ इन फेज ऑफ दिस भेज रहा हूँ, तो दैट वुड मीन कि मैं क्या भेज रहा हूँ? यहाँ पे लिखा हुआ 111, दैट मीन्स आई एम सेंडिंग 111। तो यहाँ पे मैं लिखता हूँ इन फेज सिग्नल रिसीविंग, व्हाट एम आई गेटिंग? 111। रिसीवर समझ जाता है कि इन फेज सिग्नल है तो 111 है। यहाँ पे आ गया, दिस इज से 35 डिग्री आउट ऑफ फेज, आई एम सेटिंग 35 डिग्री सिग्नल। रिसीवर समझ आता है कि ये मैं भेज रहा हूँ 110। अब यहाँ पे मैं भेज रहा हूँ, ये वाला सिग्नल भेज रहा हूँ 110 101 100। नहीं, ये दो दफा दो बिट्स चेंज हो गई हैं। 010 कर लेते हैं, एक बिट चेंज होनी चाहिए। 0 011। ऐसे मैं ड्रा कर रहा हूँ, ये कोई
सर ये
एकेडमिक
4 बिट्स नहीं आए?
है। 16 4 बिट्स
4
होंगी।
बिट्स
ओए
नहीं
ओ,
होनी चाहिए, आपने 16 के लिए।
हाँ चाहिए चाहिए। तो यहाँ पे भी एक बिट का चेंज हो रहा होगा। अब मैं यहाँ पे आ गया, फर्ज करें मैं एक एकेडमिकली देयर इज द रूल हाउ टू यू जो असाइन दीज वैल्यूज। तो आई एम नॉट फॉलोइंग दैट रूल, मुझे याद नहीं है, बट आई एम जस्ट शोइंग कि इस तरह से कोई ना कोई हम इनको, इसको हम कह सकते हैं लेटर ए, इसको कहेंगे बी सिंबल, सी सिंबल, डी सिग्नल सिंबल, और इसको कहेंगे ई सिंबल, इसको कहेंगे एफ सिंबल। ई सिग्नल कुड बी 10 0 0 1 1, this could be 0 0 0 1, and this is 90 plus 35 125 डिग्री सी फर्ज करें। So if I am getting a 125-degree out of phase signal with this, the receiver would know that I am sending 00001. So actually, when I'm sending a bit stream, I am shifting between these points at very high speed. कभी ये भेजता हूँ, कभी ये भेजता हूँ, कभी by looking at this chart over here कि मैंने ये भेजना है तो ये frequency out of phase 125 degree out of phase भेजनी. So by looking at this chart, you are actually sending these stars. कभी ये symbol भेजते हैं, कभी ये F, G, H, I, J, K, L, and so on. So by changing between these symbols, a receiver knows कि किस कौन F symbol आया है तो इसका मतलब है कि ये. What is F symbol? 125 degrees out of phase. So इसका मतलब ये कि अगर मैंने एक फर्ज करें 1 सेकंड में मैंने 4 सिंबल भेजे हैं AFDC. तो सिंबल कितने भेजे हैं 1 सेकंड में? पर सेकंड 4. बिट्स कितनी भेजी हैं? बिट्स कितनी भेजी हैं?
16
16 because A means 1111, F means 0001, D means 1011, and C means 1010. So basically I'm sending this, which is basically a signal out of phase with the fundamental frequency. So when I send 4 symbols here, I'm actually sending 16 bits. So symbol rate is much less than the bit rate. So bit rate over symbol rate you can find over here. So baud rate is the 4 symbols per second, लेकिन bit rate has 16 bits per second. So baud rate is how many times you are shifting on this point in a second. And that shifting and recognition depends how strong is your signal. दूसरा क्या समझ आ गई? कौन थे पूछने वाला क्वेश्चन हुआ? खुदा आपने पूछा था?
नहीं सर, रोशन ने शायद पूछा था।
ओके रोशन, दूसरा क्या क्वेश्चन था?
सर आपने वो मोस्ट रिलायबल जो आपने बताया था हाफ बीपीएस के वाला, वो आपने रीजन क्या बताया था कि व्हाई इज इट द मोस्ट रिलायबल?
उसमें ये है कि आप देखें ना कि एक ये सिग्नल भेज रहे हैं, एक ये भेज रहे हैं, तो दे आर 180 डिग्री आउट ऑफ फेज. दैट इज व्हाई दे आर मोस्ट रिलायबल. क्योंकि इसका इतना फेज ट्रांसमिशन में चेंज नहीं हो सकता कि ये, और वोल्टेज भी एक ही है. तो वोल्टेज इज 1 वोल्ट 45 डिग्री आउट ऑफ फेज विद द फंडा कैरियर फ्रीक्वेंसी विच इज 1 वोल्ट एंड 200 एंड कितना था 35 डिग्रीज 25 degrees out of phase. So that why it is very reliable. This is being sent like this. So BPS के and half BPS के they are very secure because आप भेजी bit rate जितना ज़्यादा baud rate to bit rate ratio, bit rate to baud rate ratio जितनी ज़्यादा होगी उतना ही ज़्यादा आप इंफॉर्मेशन सेंड करने की कोशिश कर रहे हैं, लेकिन नॉइज के साथ उतने ही ज़्यादा चांसेस हैं कि वो करप्ट हो जाए रेस्ट्रेन. So the best most secure is when you are sending only 2 points on the cancellation diagram, and you are only sending 1 bit per baud rate. That would be the most secure one. मेरा
सर
ख्याल
एक
है
और क्वेश्चन
हाँ हाँ
छोटा
पूछें।
सा
हाँ हाँ
नल मॉडेम सिस्टम का आपने क्या बताया था वो समझ नहीं आया।
नल मॉडर्न सिस्टम में देखे ना, मॉडर्न सिस्टम क्या होता है, वो आप उसमें आगे एक टर्मिनल कंप्यूटर कम्युनिकेशन इक्विपमेंट लगाते हैं मॉडेम। वो आपके जो है सीरियल बिट स्ट्रीम वंस एंड जीरोस, जो कि 0 + 5 वोल्ट होती है, उसको लेके आप, मैंने बताया था ना मॉडेम क्या करता है, उसको हाई फ्रीक्वेंसी में ट्रांसमिट करता है। अगर आपने बीच में मॉडेम ही नहीं लगाना, आपने सिंगल बिट स्ट्रीम टू बिट स्ट्रीम कम्युनिकेशन करनी है, आप इधर 0 5 भेज रहे हैं, दैट इज यूजुअली डन विद इन अ लैब और वेरी स्मॉल शॉर्ट डिस्टेंस। तो आपने तारे लगा के आप कहते हैं मैं क्यों इसको पकड़ूं और फिर मॉडेम लगा के उनको हाई फ्रीक्वेंसी पे शिफ्ट करूं, फिर वहां से फिर लो फ्रीक्वेंसी की पे लेके आऊं। व्हाई नॉट जस्ट ट्रांसमिट बिट स्ट्रीम डायरेक्टली बिटवीन टू कंप्यूटर्स? तो then you take out the modem. So ideally speaking, there should be a modem over here. जो इधर से RTX वाला जो जीरोस एंड वंस भेज रहा है वो हाई फ्रीक्वेंसी में ट्रांसमिट हो, उधर रिसीविंग एंड पे दोबारा जीरोस एंड वंस में कन्वर्ट हो, इधर रिसीव हो। इधर से जो TX कर रहा है वो हाई फ्रीक्वेंसी में ट्रांसमिट हो, इधर से फिर डीमॉड्यूलेट हो, बिट स्ट्रीम में कन्वर्ट हो, इधर रिसीव हो। तो बीच में आइडियली मॉडेम सिस्टम वुड हैव अ मॉडेम इन हियर। तो जब वो मॉडेम के बगैर ही आपस में कनेक्ट करें, जो कि शुरू में करते थे, उसका नाम लोगों ने ऐसे ही एक रख दिया, नॉल मॉडेम सिस्टम, मींस नो मॉडेम, डायरेक्ट कम्युनिकेशन। ये बीच में देखा, इससे इसको इससे कंपेयर करें, आपको मॉडेम सिस्टम है, नॉल मॉडेम सिस्टम है, और इसमें फर्क देखें। ये बिट स्ट्रीम को मैं यहाँ से शॉर्ट कर दूं, इधर से इधर ही डायरेक्ट भेजना शुरू कर दूं, और ये मॉडल मॉडेम वगैरह सारे अंदर से निकल ही जाएं, तो दैट वुड बी अ नॉल मॉडेम सिस्टम। This is one computer, this is another computer, but these two computers cannot be very far off. They cannot be. Otherwise, 0 and +5 volt, जो है ना, they will during transmission noise will be added, and you won't be able to send properly. So if you want to send any distance greater than few uh, 100 feet, you need to have a modem. Modem becomes imperative. Because as I said, frequencies don't change along the way. So FM modulation हो या जो भी हो, that can be communicated over a very long distance with very little noise being added. And that is a null modem system. Or question? हाँ भाई, any other question?
सर
Yes.
सर जो आपने ये हाफ PPSK वाला बताया था उसमें S क्या है? दो डायग्राम्स बनी हुई थी, एक S इक्वल टू 0 और 1 के लिए इवन और ऑड ऊपर लिखा हुआ था, उसका क्या मतलब है?
बेसिकली दो स्ट्रीम्स आप भेजते हैं। Input stream is divided in two streams, even stream and odd stream. And even stream is sent with these two this constellation diagram, and odd stream is sent with this constellation diagram.
ठीक है सर,
सही है।
थैंक यू।
इससे ज्यादा जो है ना, मेरा ख्याल है समझने की इसमें नहीं है चीज। अगर आप कहते हैं तो आई कैन फर्दर एक्सप्लेन इट, बट मेरा ख्याल है रहने दें, इतने काफी है, इसमें ज्यादा आगे जाने की जरूरत नहीं है, क्योंकि फिर वो और काफी सारी कम्प्लेक्सिटीज बीच में आ जाती हैं। तो बेसिकली दिस इज हाउ दे आर सेंट। So a 0 cent here and 0 cent here has a 90-degree out of phase. 1 cent here and 1 cent here is also again a 90-degree out of phase. So basically you never get a signal that is transmitted 180-degree out of phase. इससे ज़्यादा मैं नहीं बता सकता, ये थोड़ा टेक्निकल है, समझाने में काफ़ी टाइम लगेगा।
ठीक है सर।
ठीक है, अगर आपने कम्युनिकेशन का कोई भी हाफ बीपीएस के आप सर्च करें नेट पे, and see if you can understand that. ठीक है, any other question? All right, I think that's enough for today. ये जरा प्लीज ये प्रॉब्लम कर लें, इसी तरह के प्रॉब्लम्स आने हैं आपको, exactly similar problem. So do these problems. I will end here. Thank you very much. Allah Hafiz. Allah Hafiz.
अल्लाह हाफिज़।